Okay, so we're going to have a look at Cauchys' integral formula in this video. So what we're going to do is we're going to try and integrate this function here, exponential of 3 minus z over z with respect to z, over the contour gamma. Now we've got gamma is, z is absolute value of 1. So let's just draw that on the complex plane for now. So for z equals 1, we got something that looks a bit like this. That's the imaginaries, and that's the reals. Okay, so we've got 1.1 here, and the point I here, minus 1 and minus I. Now this is a simple closed contour inside the complex plane. So that's a simple closed contour in the complex plane, and the complex plane is a simply connected region. Okay, so how are we going to go about integrating this function now? So what we want to do is, using Cauchys' integral formula, we're actually not going to need to integrate. So what we do is we find the singularities and the points where this function is not analytic. So at the point z equals 0, this function here is analytic. So therefore, if we substitute in for z equals 0, we can find a solution to this using Cauchys' integral formula. So we've already looked at the rules for this. So the complex plane is a simply connected region, and we've got a closed contour here, gamma. So we just put gamma in here like this. So all we have to do now is to say the integral on gamma of exponential of 3 minus z dz over z equals 2 pi I times, and all we have to do now, this will disappear because for z equals 0, and we just plug in 0 for this z here. So we put exponential of 3 minus 0. So then all we're left with now is 2 pi I e to the 3. So 2e to the 3 pi I. So by Cauchys' integral formula, just write that one here. That is the solution to this integral. That's a nice way of doing an integral without actually doing any integration at all.